Hello students, this is Shailaja Vibhute. Let us continue the problems based on current electricity. This problem is asked in July 2016. A wire having length 2 meter, diameter 1 millimeter and resistivity 1.963 into 10 raised to minus 6 ohm meter is connected in series with a battery of EMF 3 volt and internal resistance 1 ohm. Calculate the resistance of the wire and current in the circuit. First, let us write the given quantities. A wire having a length 2 meter. So, length is given, L is equal to 2 meter. Diameter 1 millimeter. So, diameter is given in millimeter, convert it into meter. Milli prefix, so its value is 10 raised to minus 3. So, diameter is 1 into 10 raised to minus 3 meter. And resistivity. Resistivity is represented by the letter rho. So rho is equal to 1.963 into 10 raised to minus 6 ohm meter is connected in series with a battery of EMF 3 volt. So EMF E is equal to 3 volt and internal resistance 1 ohm. Internal resistance is denoted by small r. So R is equal to 1 ohm. Calculate resistance of the wire. So resistance of the wire means capital R is equal to how much and current in the circuit. So I is equal to how much. So how to solve this problem? These are given quantities. Now let us solve it. To find resistance R, use this formula. R is equal to rho L divided by A. So substitute the values now. Rho is 1.963 into 10 raised to minus 6 into L value is 2 meter. So into 2 divided by area is not given. So let us write it as A. Okay. You can name it as equation 1. Otherwise you can continue like that only. Now let us find area A. Since it is a wire having some diameter, so area of the wire is calculated using the formula A is equal to pi r square. R is radius. So here diameter is given. You can convert that diameter into, means you can write for radius or directly you take relation between radius and diameter as d by 2. Radius is half of the diameter. Since here it is r square, so you take it as d square divided by 2 square. 2 square is 4. So pi r square can be written as pi d square by 4 because diameter is given. Now substitute the value. Pi value is 3.142 into diameter value is 10 raised to minus 3. So 10 raised to minus 3. Square is there, so take square divided by 4. Simplify this one, you will get 0.7857 into 10 raised to minus 6 meter square. So you got the value of area now. Okay. Now what we have to do? We have to substitute it in equation 1. So if you substitute it in equation 1, you will get R is equal to 1.963 into 10 raised to minus 6 is rho value into L value is 2 divided by area. Just now we have calculated, it is 0.7857 into 10 raised to minus 6. Simplify this one, you will get resistance R is equal to 4.9968 ohm. Approximately you can write it as R is equal to 5 ohm. Otherwise you can write like this one. So first unknown quantity we have calculated, that is resistance. Now let us find current. To find current in the circuit, you can use the formula I is equal to E divided by R plus R. Now substitute the value. E value is 3 volt, EMF is given, divided by R value, just now we have find out, that is 4.9968. Small r value is 1, so plus 1. Simplify it, you will get I value is 0.5 ampere. Ampere is unit of current. So you have calculated resistance and current in the circuit. So like this you can solve the problem very easily. Okay, now let us go for next one. This problem is asked in March 2016. 3 resistors of resistances 2 ohm, 3 ohm and 4 ohm are connected in series. So 3 resistors are connected in series. What is the effective resistance of the combination? So for this series combination, what is the effective resistance? If this combination is connected to a battery of EMF 10 volt and negligible internal resistance, obtain the potential difference across each resistance. So this is given problem. Now let us see how to solve it. So what are given quantities here? 3 resistance values are given, 2 ohm, 3 ohm and 4 ohm. And EMF of the battery is given. Negligible internal resistance means internal resistance is 0. Negligible means 0. You have to find out effective resistance, that is RS, you have to find out because it is series combination. Then you have to find out PD across each resistor, that is say V1, V2 and V3. Let us see how to solve. For that, first write given quantities. R1 is 2 ohm, R2 is 3 ohm, R3 is 4 ohm. Then EMF is given. You can write EMF, or here voltage is given, that is 10 volt, internal resistance 0. Then RS is equal to how much? Then V1 is equal to V2 and V3 values how much? So to find RS, I hope you are remembering. For series combination, formula is RS is equal to R1 plus R2 plus R3, so on. Correct. And in series combination, current remains constant, current remains same, and potential divides. So V1, V2, V3 you have to find. RS is equal to R1 plus R2 plus R3. So 2 plus 3 plus 4, it is 9 ohm. Then we have to find out V1, V2, V3. To find V1, V2, V3, you can take the help of Ohm's law. Ohm's law is V is equal to IR. Since resistance value is given but current is not given, first we have to calculate main current I. So how to find out main current I? I is equal to V divided by RS. Series combination means effective resistance you have to take. So I is equal to V value is given, that is 10 volt, divided by RS value is 9. So when you simplify you will get 1.11 ampere. Now take PD across R1 as V1 is equal to IR1. Substitute the value, 1.11 into 2, it is 2.22. Similarly, PD across R2 is V2 is equal to IR2. After substitution you will get 3.33 volt. Then PD across R3 is V3 is equal to IR3, that is 1.11 into 4 is 4.44 volt. So you have calculated effective resistance as well as PD across R1, R2 and R3. Now let us take next one. This problem is asked in July 2017. 3 resistors 4 ohm, 6 ohm and 8 ohm are connected in parallel. Okay, now parallel combination. What is the total resistance of the combination? Means RP you have to calculate. If the combination is connected to a battery of EMF 25 volt and negligible internal resistance, determine current through each resistor and total current drawn from the battery. So as we know this one, in parallel combination, potential remains the same, current divides. So we have to calculate current through each resistor now. So let us write first given quantities. R1 is equal to 4 ohm, R2 is equal to 6 ohm, R3 is equal to 8 ohm, Rp is equal to how much? Then EMF E is equal to 25 volt, negligible internal resistance, so small r is equal to 0. Then we have to find out I1, I2 and I3. To find I1, I2, I3, definitely I is required, that is current in main current is required. So that also we have to find out. Now to find Rp, what is the formula? 1 divided by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula. Now substitute the value 1 by 4 plus 1 by 6 plus 1 by 8. This you can solve either by taking LCM, or since you are using calculator, directly you can write 1 by 4, 1 by 6 and 1 by 8 values. Then add it. So 1 by 4, 0.25 plus 0.166 plus 0.125. Add it, you will get 0.5416. This is value of 1 by Rp. So you have to find out Rp by taking reciprocal of it. So reciprocal of that value is 1.8436 ohm. Okay, this is very important because when you are calculating parallel combination, your value is for 1 divided by Rp. You have to calculate Rp, that's why you have to take reciprocal of it. So what is value of Rp now? 1.8436. Now to find main current I, the formula is E divided by R plus R. But here parallel combination, so you write it as Rp. Okay. Then substitute the value now. I is equal to 25 divided by Rp value is 1.8463. 1.84 plus 0. Then you will get I value as 13.54. Now to find branch currents, you can use the formula I1 is equal to V by R1. Then 25 by 4, 6.25. I2 is 4.16 ampere and I3 value is 3.125 ampere. So like this you can solve it for parallel combination. Okay, now let us go for next one, that is March 2017. When two resistors are connected in series with a cell of EMF 2 volt and negligible internal resistance, a current of 2 by 5 ampere flows in the circuit. When the resistors are connected in parallel, the main current is 5 by 3 ampere. Calculate the resistances. So here given problem is, first two resistors are connected in series, then for series combination current is 2 by 5 ampere. When the same two resistors are connected in parallel, current becomes 5 by 3. You have to find out values of resistances. So let us write given quantities. EMF of the cell is given 2 volt. Negligible internal resistance, so R is equal to 0. Then for series combination, I have taken. You can write only I or I1 you can take. 2 by 5 ampere. IP means for parallel combination, current is 5 by 3 ampere. You have to find out resistances. So R1 is equal to how much? R2 is equal to how much? Now take one by one. First let us go for when two resistors are in series. So when two resistors are in series, formula is I is equal to E divided by Rs plus R. We don't know resistances, so since small r is 0, neglect it. You shift Rs here and take I here. You will get Rs is equal to E divided by Is. Okay. Now substitute the value. E value is 2. Then Is value is 2 by 5. When you simplify, you will get 5 ohm. Then when two resistors are in parallel, so you will write Rp is equal to E divided by Ip. So E value is 2 divided by Ip value is 5 by 3. Simplify it, you will get 6 by 5. So Rs value you got 5 ohm and Rp value you got 6 by 5. Next. So 6 by 5 can be written as 1.2 ohm. So when two resistors are in series, means Rs is equal to how much we got? 5. But Rs is equal to R1 plus R2. How much we have? 5. Let us name it as equation 1. Then let us write Rp formula. When only two resistors are in parallel, formula is Rp is equal to R1 R2 divided by R1 plus R2. Okay. Rp value is how much? 1.22. R1 plus R2 is how much? 5. But we don't know R1, R2. So you write R1, R2 is equal to, shift it this side, you will get R1 plus R2 into Rp. Substitute the value. R1 plus R2 is 5. Rp is 1.2. You will get 6 ohm. So R1 plus R2 is 5. R1, R2 is 6. Let us name it as equation 2. Now let us use one relation here. That is A minus B whole square is equal to A plus B. Here you make it as A plus B. This one. A plus B. This is A plus B whole square. Here by mistake it is A minus B. You make it as A plus B. Okay. This one. Here. Hope it is clear now. Here I have written A plus B whole square minus 4AB. So let us apply to ours, that is R1 minus R2 whole square is equal to R1 plus R2 whole square minus 4R1 R2. Substitute the values now. 5 square minus 4 into 6. So you will get R1 minus R2 whole square as 1. Now this can be written as R1 minus R2 is equal to 1. Name it as equation 3. Now let us solve equation 1 and equation 3 simultaneously. R1 plus R2 is equal to 5. R1 minus R2 is equal to 1. Plus R2 minus R2 get cancelled. So you will get 2R1 is equal to 6. Correct? Wait. Here when you solve equation 3 and equation 1 simultaneously. So you will get R1 plus R2 is equal to 5. R1 minus R2 is equal to 1. Okay. This get cancelled. R1 plus R1 is 2R1 is equal to 5 plus 1 is 6. So R1 is equal to how much? 3 ohm. Okay. Now substitute it in any one equation. You will get R2 value as 2 ohm. Is it clear? So R1 value is 3 ohm and R2 value is 2 ohm. Okay. So you got values of two resistors. Now let us take last problem. Two cells of EMF 2 volt and 4 volt and internal resistances 1 ohm and 2 ohm respectively are connected in parallel so as to send the current in the same direction through an external resistance of 10 ohm. Find the potential difference across 10 ohm resistor. So here two cells are connected in parallel. So when two cells are connected in parallel, first let us write the given quantities. EMF of first cell is 2 volt. Its internal resistance is 1 ohm. So E1 and R1 values are given. E2 and R2 values are 4 volt and 2 ohm respectively. Then capital R value is given, that is external resistance 10 ohm. You have to find out potential difference. So V is equal to how much? To find V, we have to take the help of Ohm's law. So to take the help of Ohm's law, V is equal to IR. R is given, but what about I? To find I, we have to use this formula. I is equal to E divided by R plus R. But here, since cells are in parallel, so capital E means it is E equivalent and internal resistance is nothing but R equivalent. So how to find E equivalent and R equivalent? Use this formula. E equivalent formula for parallel combination is E1 R2 plus E2 R1 divided by R1 plus R2. Substitute the value, you will get 2.67 volt. Then R equivalent is R1 R2 divided by R1 plus R2. Substitute the value, you will get 0.67 ohm. Now use the formula I is equal to E equivalent divided by R equivalent plus capital R. Substitute the values, 2.67 divided by 0.67 plus external resistance is 10. When you simplify, you will get 0.25 ampere. Now use this Ohm's law. Potential difference V is equal to I into R. I value is 0.25, R value is 10. So you will get the value 2.5 volt. Based on current electricity, you can solve number of problems. You can practice the problems so that you will be confident in solving the problems. Thank you.